For the next part of creating a design storm, we'll use what's called the alternate block method. The alternate block method is a little bit of science and engineering. It's a little bit of art. What we do is we'll use the intensity, duration, frequency curve for a particular storm event. And I'm giving you one here. This is the 10% AEP 2-hour duration storm. And it's got a curve based on duration. So the storm we'll be designing to is a 2-hour duration storm. This curve, this equation, which is plotted down here, gives you the intensity for any duration within the limits of the data. So what you'll do is take this equation, you'll plot it out based on 10-minute duration intervals, and then you'll calculate the intensity. So that's the first step, is we'll actually plot this intensity, duration, frequency curve. So it's just for the 10% storm event. Then the next step of alternative block method is we take this IDF curve. And the reason why we have this method in the first place is because maybe we don't have good gauge data or a temporal sequence. So we'll kind of just make one up. We, not using NOAA time series and that sort of thing. So though IDF curves are much more common, you can get them regionally and that sort of thing. So this is a hydrograph based on the IDF curve. After we plot this curve, we'll create a cumulative depth column in inches. And so that's going to add the incremental precipitation based on the intensity column. So here's our intensity column. And then we'll add incremental cumulative depth. So this has units of inches. Intensity has units of inches per hour. So what I'm doing here then is I'm taking the intensity and then just multiplying it by that increment, 10 minutes, right? The next increment is 20 minutes. So it's not just 10-minute increments, it's the cumulative increment, all the way to 120 minutes. So I'm dividing by 60 to get units of hours. So inches per hour times hour gives us inches. All right, so this is cumulative depth, or just kind of overall depth for a particular storm event. So if I have a storm event that is 120 minutes of duration, and the average duration in inches per hour is 0.82, then the depth over that storm event is going to be 1.64 inches of rainfall, okay? Now, the next step then is to look at incremental depths between these. So here is the overall depth of rain for a particular duration storm event. Now I want to know what is the difference between these two, right? So 0.69 minus 1 gives us 0.31. So here's the difference in depth between these particular events. So here's that table reproduced here. So now what we're going to do is sort our incremental depths in decreasing order. And we'll just go ahead and do that now so we can, actually, I'll just kind of paste it down here. So I sorted them in decreasing order. So the first one is still the first one, 0.69 inches, and all the way down. It should line up, but it might not be perfect. So you might need to do some sorting on your own. And we give it a rank. And now we're going to actually construct the hydrograph. And what we end up doing, let me just kind of show you what the end result is, and then we'll kind of backtrack. We end up taking these incremental depths and kind of distributing them around a hydrograph. So we said we want a 2-hour storms. We go all the way to 120 minutes. We put the biggest increment in the middle, and then we just start alternating. And this is what alternating block method is. So we take the next increment, put it on the right, take the next one, put it on the left, and repeat until we get this quasi-symmetrical, not quite symmetrical hydrograph with the biggest one occurring in the middle. So that's what I'm doing here. So I say location, okay, middle, at 60 minutes, after, before, after, right? And now I can just follow that and I'll say, okay, here's my middle interval. So I'm going to drag 0.69 to the middle. And then I'm going to go after, so 0.31. I can just drag that and go after. and then 0.18, I'm going to go before, 0.12 after, 0.6, 0.8 before, and so forth. So I'm alternating, right? And then the total depth, I sum that up and it should be 1.64. If you look at that, you'll notice that the total depth over the 2-hour storm is 1.64. So granted, this is kind of a really synthetic type of approach. At the same time, we still get the total depth as the same. So based on this intensity, duration, frequency curve, I get that 1.64 for the total depth over 2 hours. And again, this is intensity, it's not total depth, right? So we have to multiply it by the time to get the total depth. So I'm kind of, quote unquote, conserving mass or getting the same rainfall depth I would if I were just to do a uniform distribution. But this takes a uniform flow depth or intensity over time and divides it up and makes a synthetic hydrograph or hyetograph using the alternative block method. And then the last step is just to plot that, which we show here and as well as in the handout using a bar graph.